Okay, so this is the first of two lectures that I'm going to give on the background of group theory, which is the theory that we use for talking about symmetry of molecules. This is optional, meaning that you don't need any of this in order to understand the material we have in the class, but I thought it might be helpful, especially if you have a good mathematical background. Okay, so let's talk about a group. A group is a collection of elements that are interrelated according to a set of rules. So rules mean that we have, so for instance, there are some rules about members of the group and how they interact and what that relationship is. What is a product? So how we define a product. So for example, the set of all integers, positive and negative, and 0 constitute a group when the product is addition. We define the product as addition. Okay, some of the rules for groups. A product of any two elements of a group must also be an element of that group. So if I have some element A and I operate that onto B, which gives me some element C, then C must also be an element of the group. One element of the group must commute with all of the others and leave them unchanged. So the example we used before where we said, what about all integers? If the product is addition, then what we have is that that element is going to be equal to 0. So any number added to 0 is going to give that same number back again. If it's real numbers in multiplication, then that value is 1. The associative law must hold for elements of the group, namely that if I have A operating on B and C must be equal to A, if I do A first, then B, and operate that onto C, the two of those must be the same. On the other hand, commutation is not necessary. It's not necessary that A, B is equal to B, A. Okay, every element must have a reciprocal, which is also an element of the group. And the reciprocal is, excuse me. So I'm going to step through each of these rules for a moment so get a little more detail. First off, the product that any two elements of a group must also be an element of the group. This also applies to the square of any element of the group. So A times A gives me an element. That element must be in the group. I'd mentioned earlier we need to define what the product operation is for the group. Our group could be vectors, and the product might be cross product, or it might be they could be matrices, and then the matrix multiplication gives me is my operation. As I mentioned previously, commutation does not necessarily hold. It is not necessary that AB is equal to BA. And we've seen that with other operators. Okay. We said that one element of the group must commute with all the others and leave them unchanged. Okay. So we're going to give this element the identity. We're going to call this the identity element E. So E times X is equal to X times E is equal to X. So so in the group of integers, I mistake the integer 0 corresponds to the identity element, because if my product is addition, then any integer n plus 0 is equal to 0 plus n is equal to n. If we're talking about integers and product, the operation is addition. If, on the other hand, we're talking about real numbers, just like all real numbers. So now, and actually I think it would even work for probably rational numbers, the set of rational numbers, then, and we use multiplication for the product, then the integer 1 is going to correspond to the identity, namely that 1 times any real number is equal to that real number times 1, which is equal to that real number. Okay. We mentioned that the associative law of multiplication must hold for elements of the group, and we've just represented it this way, and we've seen that already. Finally, the last piece is that every element of the must have a reciprocal, which is also an element of the group. So the element R is the reciprocal of the element S if RS is equal to SR is equal to E. We might even put, and if R is the reciprocal of S, then S is the reciprocal of R. Remember, if I talked about the idea that if we looked at our set of all rational numbers, that then, and we use math, and if we used multiplication as our operation, now if my number is 3, then the reciprocal, of course, is 1/3, and the product of them is 1, which is the identity element. Okay. So one term we should look at is the order of a group. So the order of a group is the number of elements in the group, and they can be finite or infinite order. We're working with groups that are symmetry elements of a molecule, and so we're not going to have an infinite number. Well, we might have an infinite number of planes for linear molecules, which we'll see, but really it's they all get treated the same. So we're using much smaller orders here. And and finally, so I used the example of integers. The combination law is normal addition of integers. So rule 1 is satisfied. The identity element of the group is 0. 0 times, in this case, 0 plus any integer. The associative law does hold, and the reciprocal of any integer n is minus n. And that's all we have for basic ideas of group theory. Next lecture we'll have is on group multiplication tables.